Hi, this is Lori, and welcome to my series on the Pico W. Today, I'm on the road, traveling in my RV, and I wanted to get this project out. In this project, we're going to have 3 episodes, and the goal will be to create a digital Etch-A-Sketch with our Pico W. The first step in doing that will be learning how to use a display to be the display part of the Etch-A-Sketch. So this episode will teach you how to connect up an OLED display to the Pico W. Let's get going. The OLED display we'll be using for this project is the SSD1306 OLED display, and that designation is the driver chip for this display. They're very common and a lot of people use them in beginning electronics projects. The one I have actually is called a 1315, but it runs with all the libraries that use the 1306. And I actually have 2 different versions of them in my lab. I have this one here that's 128 by 64 pixels, but there's also a version that has 128 by 32 pixels, so a little bit less tall of a display. For the Etch-A-Sketch, it'll be better to use this size display so we have a little more screen space. These things are pretty tiny, and when you see them actually on the breadboard with the Pico, you'll see what I mean. They can be 2-color displays, but they're really just a monochrome display. If it has different colors, it's just that part of it's been coated with a different gel or something on the screen to make it shine different colors. It has 4 pins. A power pin, a ground pin, and then a serial clock pin and a serial data pin. That's the I2C communication pins that will connect up to our Pico W. To use the 1306, we'll need to load that library through Thonny using the Tools menu and the Manage Packages to find the SSD1306 library. It'll be called MicroPython underbar SSD1306. So that's something you'll need to get in place so we can use this. Here's the circuit we'll be using to connect up our display to the Pico. We push the display into our breadboard. It has little pins behind it, and we'll connect it up to ground, power, and then we need to connect the clock and data pins for the I2C communication up to similar pins that will do that function on our Pico. This is where the pinout for the Pico really starts to become very valuable to us. When we look at the pinout, we'll see that one of the functions that the pins can do are the I2C functions for communication, and they're labeled here in the blue colors on this particular pinout diagram. There's 2 of them, a 0 and a 1, and you can see the data and clock functions here. I'm going to be using the first 2 pins on the Pico, and that's I2C 0, data, and clock. To use our display, we need to understand a little bit about how the pixels are addressed as a grid, and then also something about frame buffers. By grid, I mean, how are the pixels numbered? How can we refer to them? On the display that we're using, the upper left corner will be numbered 00, so that'll be pixel 00. If we go to the right, we'll go all the way up to pixel number 127, giving us a total of 128 pixels wide. And then we'll have, as we go down, will increase up to 63, giving us the 64 pixels. And you can see over in this corner, that final pixel over here would be pixel 12763. That's how we'll address the pixels as we try to manipulate the display and create various graphics that we want. The next thing we need to know a little bit about is frame buffers. And it's an area of memory that's held aside where we work on kind of building up our next display, our next screen we want to show on our display. And once we make all those changes in the memory, saying, you know, what kinds of objects we want drawn or what pixels we want turned on, right here waiting in that frame buffer, then we can use the show method to send them to the display so we can see them. I put together a couple of slides on the drawing methods in the framebuf library. The first is the text method. It allows us to put text on the screen starting at the place we point out. And there's also a color option. You'll see there's a color option on almost all of these methods. In our case, we only have a monochrome screen, so it's either a 0 or a 1, turned off or turned on. And you know, the text is fairly small. It's 8 by 8 pixels, but the screen is pretty small, so this text seems to fill in the screen pretty well. We can fill the whole screen with a color. That's a way we could kind of wipe off the color by turning everything black, so clear the screen. We can address individual pixels. We can have horizontal and vertical lines. We can draw lines from a point to another point. We can do rectangles, and we can fill the rectangle or just have it be an outline. We can also do ellipses, which a circle is ellipse where the radius is the same in both the X and Y direction, and polygons as well. There's also a scroll method that allows us to scroll the active display along a vector. And then there's this blit method that allows us to put another frame buffer on top of the current one at a specific coordinate. And we'll see how that works as well. First, let's take a look at the actual circuit. We saw a drawing of it, but here's our display. Here's our Pico. And we've got power and ground coming off of our Pico here. I'm passing it around to the other rail, and we're connecting ground and power, and then we're connecting to the two I2C pins that we selected from the pinout diagram. So GPIO 0 and GPIO 1 are connected back to those pins on our display. So that's how everything is set up, and pretty easy to use. I'll just pull it out a minute. You may receive these when you buy them. You might not have headers already in here. You may have to put some headers in yourself, but it's relatively easy to do, and then it's very breadboard friendly that way. So that's how I have it plugged in to the breadboard. We'll need to have the SSD1306 library installed, and if you've never done that in Thonny, it's really pretty straightforward. You go to the Tools menu and pick Manage Packages, and then search it up. So I'll go ahead and type in SSD1306, and we'll see the search results, and you can see there's a lot of different ones to choose from, and that can sometimes be confusing. But the one we're looking for is MicroPython-SSD1306. So you click on that, and you can see I already have it installed, so I won't install it, but you'll be able to click a button down here that says Install to get it going. Time to try out those methods from the framebuf library. First thing we'll need to do is set up our I2C bus and set up our display. We'll need to import from the machine library pin and I2C, and then from the SSD1306 library, SSD1306 underbar I2C. We'll set up our I2C bus. We could name it whatever we want here, but we use this function. We tell it we're using the 0. Remember, there's a 0 and a 1. We saw that on the pinout. And the two pins that we're going to use for data and clock, so 0 and 1. Then we're going to set up our screen, our OLED, using this function. We tell it the width and the height and the bus that we're going to connect it into and the address of this device. This particular OLED, this is the default address for that device, but I have found it a little more reliable when I go ahead and specifically include it here in the setup. Then we'll initialize the display, which kind of clears everything out and gets it ready to go. Let's copy that into our shell and see if that's all going to work for us without any errors. And you can see everything came back fine. Of course, nothing's on the display because we haven't used any methods yet. So the first method we'll try is the text. we'll write Etch-A-Sketch starting at x equals 0, y equals 0. Then we'll drop down 16 pixels. So we'll start this piece of text at 016, and then we'll write Lori's robots at 032. So I'm giving enough space for this text. Remember, it's 8 by 8 pixels, so I need at least 8 pixels separation as I write various lines of text to the screen. Let's go ahead and copy those over, put them in the shell here. And you notice that the display does not update when I put them. We're only updating the frame buffer, the area of memory that is in waiting to go and be sent to the display, and we'll send it to the display using the show method. Go ahead and do that, and hopefully our text will appear. There we go. Looks pretty good. All right, let's try a few more of these. The fill will fill the entire screen, so let's try that one. We'll go ahead and fill the whole screen, turn it all on. There we go. Yep, all white now. Next we'll demo the pixels, so we can turn on and off individual pixels. So the first thing I'll do is just fill the whole screen with black, turning it all off again. And then we'll turn on just these pixels at x is 20, y is 5, x is 20, y is 20, and then y is 40, and y is 60. So should we get 4 pixels arranged that way? Let's see how it goes. And there they are, pretty small. Those pixels are teeny on this little screen, but you can see that 4 of them have been turned on. Next up are the line methods. So we have the horizontal, the vertical, and the 2-point line. We'll clear the screen again, and we'll put a line starting at x equals 5, y equals 0, and it'll go 127 pixels, so it'll go all the way across. And then we'll do a vertical line at 50 and 0 and go all the way down. And then we'll draw a line from 2 points, the 0, 0 point to the opposite corner, 127.63, and we'll go ahead and show that. Let's try that. We'll do that. Very good. Yeah, worked out perfectly. We can see the horizontal, the vertical, and the 2-point line from corner to corner. Alright, we got a few more to try. How about the rectangle? We'll draw 2 rectangles starting at 5, 20, so x equals 5, y equals 20, and we'll give it the width and the height. So this is going to be a rectangle because it has a different width and height. And I'm not putting a true here on the end of this one, so this one will just be an outline of the rectangle. And in the second one, I'm going to make a square starting at x equals 70, y equals 20. We'll go 30 in each direction, and because I put the true here at the end, that means it's going to get filled. Let's see what that'll look like. All right, paste that down here, and there we go. We can see our rectangle and our square that's filled. And last, we're going to draw a circle and an ellipse. So with the circle, this will be the center at x equals 20, y equals 16, and it'll be a circle because the 2 radius that we're using in the x and the y direction are equal to each other. That'll get us the circle. And then we'll draw an ellipse, start at the centering at 80, 40, and it'll have radius of 40 and 20, and it'll be filled because I put the true here, just like with the rectangle method. So let's try that. See how that looks. All right, and there we go. There's our circle and our ellipse. So a quick introduction to the framebuf methods. They'll be useful in drawing various kinds of graphics as we go along and make good use of this display. Now you may be interested in putting a graphic that you already have an image file for onto your OLED display, and that is possible. And I've just learned how to do this myself, so I'm no expert, but most people seem to use a piece of software called GIMP to set up their image so that it's in the right format for MicroPython to display on our 1306 display. GIMP stands for GNU Image Manipulation Program, and you can see I'm at gimp.org here, and this is where you will go to learn about GIMP and to download the version for whatever system you have. So you'll want to download that if you want to do this next part where we'll put an image on our OLED display. I have GIMP open on my computer, and we're going to bring in the file that we want to set up for our display. So I'm going to say File, Open, and on my desktop I have the Raspberry Pi logo. Now it's much larger in pixel size than we're going to be able to display. It's also a color too, so we're going to remove the color and turn it into a black and white image inside of GIMP. So we'll go ahead and open that. And a dialog box will talk about how it's going to try to convert this into a form it can read, and we just say convert and it'll come into GIMP. So that's great. Next we're going to resize this and get it the right size for our screen. So I'm going to right click on it and choose image, and then I'm going to choose scale image. You can see how large it is. Well, the dimension that we're going to have the hardest time with is the height, so we need to change it to 64 pixels high and go ahead and click scale, and you can see it gets much smaller. So I'm going to go down here and zoom in a little bit more on it. You can already see we lost a little bit of the clarity of the picture. Let's right click on it one more time. And now we're going to set the canvas size. So we want to set the canvas size to the size of our screen. So I'm going to do 128 by 64. And I'm going to click center to put it right in the center of the display size, canvas size, and click resize. There you go. Now we have that done. Now we're going to start converting it. So we'll go up to the image and we'll choose mode indexed, and we also need to use a black and white 1-bit palette. So that's going to turn this into a black and white image now, and you can try different forms of these dithering to see what might work best for your display, and click convert, and there we go. We can see now we have the Raspberry Pi logo as a black and white image. And last, we just need to go up to the File menu and choose Export As. And down here, we'll have to select the file type we want. So we'll select the file type, and we'll come down and we're going to look for PBM image. Portable bitmap is what it stands for. We'll say that's what we want. We'll say give it a name up here that you want, and go ahead and click Export. When you do that, it's going to ask you whether you want it in ASCII or RAW. You want it in the RAW format, and go ahead and click Export. And now you should have the image in the right format, and we're going to upload that image to our Pico. Here are the instructions written out on how to convert the file using GIMP. You can pause the video and take a screen capture to remember. To show the Raspberry Pi logo that we just converted in GIMP on our OLED display, we'll need to upload that portable bitmap file onto the Pico. So we'll click on it here, search around to wherever you put it, and right click on it, and then upload it to Slash, and that'll send it to the Pico. You can see now it's on the Pico, and now we got to write some code to display it. We'll import the needed modules, but we'll also need to import framebuf because we're going to use another function. Then the same setup for the bus and the display that we had before. And then we're going to read in that portable bitmap file into a byte array, which is a special data type in MicroPython. And we're going to read that in. And we have to skip over the first 3 lines, so that's what this open file thing does. It skips these first 3 lines and then it reads the rest of the data. That's the image portion, which are just zeros and ones, into the byte array so we can display it. We'll create a buffer using the framebuf library with that byte array data with the right width and height and indicating it's a monochrome type screen. Then we'll display the image using that blit method display the buffer at the 0, 0, so we're going to show the whole display, and go ahead and send it to the screen. Let's go ahead and run it and see if it goes. There we go, and we can see we have our Raspberry Pi logo now on our OLED. So interesting way to get graphics on there. It can be challenging when they're all colorful, and you may have to spend some time kind of cleaning them up, but with GIMP you can convert a lot of different images into the format you need for this tiny little display. A lot of fun. Well, I hope you enjoyed this part of our project. Getting to know this 1306 display is a key component to making our Etch-A-Sketch. And next episode, we'll learn about potentiometers, because they'll be the dials for our digital Etch-A-Sketch. See you next time.